Good morning, students. Today we started the first chapter, application of matrices and determinants. The first one is a matrix. You know, a matrix is a collection of some elements. It is our choice, we put any elements. For example, I put 1, minus 2, 3, 4. So we have collected 4 elements like this, 1, minus 2, 3 and 4. So this is called a matrix. What is the order of the matrix? Order means it has how many rows and how many columns. It has how many rows? There will be 2 rows, 1, 2. And how many columns? Same, 1, 2. So how to write the order is 2 by 2. Okay, it's called a matrix. So matrix is nothing but a collection of some elements. We arrange the 4 elements. I do one more example. Another matrix B. 1, minus 5, 3, 4, 2, minus 3. I arrange some 6 elements. 1, minus 5, 3, 4, 2, minus 3. Now you say, what is the order of the matrix? Order means it has how many rows and how many columns. How many rows are there? 1, 2, 3. So 3 rows. So first we write 3. And how many columns are there? There will be 2. 1, 2. So it should be read it as 3 by 2. So this is called the matrix. So what is the use of the matrix in our real life? Suppose we arrange some persons according to a rank wise. The first rank, second rank, third rank will arrange in the first seat, suppose. So we arrange 1, 2, 3. And the next rank arrange in the next row. So 4, 5, 6. So this pass is going. So that's why the matrix is important in our real life also. Or we arrange as persons in the highest height. The highest height of the person, suppose, seated in the last row. And then the smallest height arranged in the first row. So in this case, the matrix is important in our real life. So it is a matrix. So matrix is nothing but a collection of some elements. So we leave 1, minus 2, 3, 4. Suppose I change minus 1, plus 2, minus 3, and it's also a matrix. You know very well, all the matrices are denoted only by the capital letters. So ABC like this. And the next one is determinants. So matrix over. The next one is determinants. What is meant by a determinant? So matrix has no value, but a determinant has some value. For example, I will take one matrix A, 1, minus 2, 4, minus 1. So it is a matrix E. So it has no value. We collect some 4 elements. Now to find the determinant of this matrix. You know the determinant symbol. So it is called determinant. How to read? You should be read it as determinant E. And the determinant symbol, we write between the 2 parallels. We do the same work. 1, minus 2, 4, minus 1. A matrix has no value, but a determinant has some value. It may be a positive or negative or 0. How to find the determinant of a 2 by 2? You know the working rule? We already see in the 11th standard also. I tell again. What is the working rule? First we multiply the leading diagonal elements. So we multiply these 2 elements first of all. 1 into minus 5 is minus 5. The next step, we multiply the remaining 2 elements with a minus. So we multiply these 2 elements with a minus. So we put 1 minus. Now we multiply these 2 elements. 4 into minus 2. 4 into minus 2, minus 8. So minus 5. Minus into minus is plus 8. Minus 5 plus 8. The value is 3. So value of the determinant is equal to 3. So matrix has no value, but a determinant has some value. It is a positive value. or some cases it may be a negative value or it become 0 also. The next definition is singular and non-singular matrix. Suppose determinant of any one of the matrix value is equal to 0, we say the matrix is a single. If determinant of the matrix A is equal to 0, then we come to the conclusion A is a singular matrix. And the next one, suppose whose determinant value is a non-zero, it may be positive or negative, is a non-zero, then we say A is a non-singular matrix. Okay, determinant value is equal to 0, then the matrix name is singular. Determinant value is a non-zero, then the matrix name is a non-singular. I'll give one example of both singular and non-singular. I will take the matrix A value is 1, 4, 4 and 16. Okay, it is a value of the matrix A. Now we find the determinant of this matrix. Okay, so determinant A is equal to determinant symbol. We write the elements 1, 4, 4, 16. Now to find the determinant of this determinant, what is the first rule? We multiply the leading diagonal elements. 1 into 16. 1 16s are 16. The next step, we multiply the remaining two elements with a minus. So we put one minus. Now we multiply 4 4. 4 4s are 16. 16 minus 16 become 0. Determinant A value is equal to 0. So A is a singular matrix. Determinant of any matrix value becomes 0. It is called a singular. So non-singular means the determinant value cannot be 0. Suppose I will do one more example. I will take one matrix B. Suppose that value is 0, minus 5, 2 and 3. It's a B matrix. Now we find the determinant of the matrix B. So determinant B. Determinant symbol 0, minus 5, 2, 3. Now we find the determinant of this one. What is the first step? We multiply the leading diagonal elements. 0 into 3, 0. The next step, we multiply the remaining two elements with a minus n. So first we put one minus n. Next we multiply these two elements. 2 into minus 5. 2 into minus 5 is a minus 10. So determinant B value is equal to 0. Minus into minus is a plus 10. 10 value is always non-zero. Determinant of the matrix B is non-zero. Therefore B is non-zero. Determinant value is not equal to 0, then it is non-zero. Determinant is equal to 0, then we say A is a singular matrix. It is useful in our next topic. So I explained singular and non-singular matrix. Now we introduce two more matrices. One is adjoint and another one is inverse. Now 12 is the first one. One is the adjoint of the given matrix and another one is the inverse. First we see the 2 by 2 matrices. 2 by 2, 3 by 3 and 3 by 4. So many matrices there. First we see a 2 by 2 matrices. How to find the adjoint and inverse of 2 by 2 matrix. One matrix is given to find adjoint and inverse. So adjoint is the modifier of the given matrix. I will give one example. I will take the matrix A. Suppose whose values are -1, 0, 2, -4. Suppose is the value of the matrix A. To find the adjoint of the matrix, that is, we modify some elements, it has some rule, but one shortcut form is the, so I tell the shortcut form. So what is the adjoint of the given matrix A? Is the matrix A. To find whose adjoint. You see, in adjoint, ADJOINT, the symbol of adjoint is shortly denoted as ADJ. Okay, adjoint shortcut form is ADJ. So adjoint of the matrix A is denoted by adjoint A. Okay, given matrix is A. To find adjoint of the given matrix A, it has some working rule, but I will tell in shorthand form how to find the adjoint of any 2 by 2 matrix. Now we find adjoint of the matrix A, so I write adjoint of A. Suppose the matrix name is B, we write it is adjoint B. So what is the working rule to find adjoint of any 2 by 2? The first working rule is we interchange the leading diagonal elements. You know, it is the leading diagonal elements. We interchange. Interchange become -1, -4. -4, -1. And next one, change the sign of the remaining 2 elements. Sign only. Sign means it has a plus, we put minus. If it is minus, we put plus. But 0 is there. -0 is also 0. And 2 is there. So +2 is there. So we put -2. It is a shortcut form to find the adjoint of any 2 by 2 matrix. I will give one more example. Suppose the matrix is C, whose values are 1, -2, +5 and -9. To find adjoint of the matrix is C. So symbol of adjoincy is ADJ of the matrix C. So adjoint of C is equal to, what is the working rule? The first step is we interchange the leading diagonal elements. What are the leading diagonal elements here? 1 and -9. We interchange. So it becomes -9, 1. The next step is change the sign of the remaining 2 elements. -2 is there. So -2. So we put +2. +5 is there. So we put -5. So it is a working rule to find the adjoint of any 2 by 2 matrix. And the next one is inverse. One matrix is given to find the inverse of the matrix. Okay, what is meant by inverse? In multiplication, I will take one number 6. What is the multiplicative inverse of 6? The multiplicative inverse of 6 is 1 by 6. Because we multiply this number, we get a multiplicative identity. So we say 1 by 6 is a multiplicative inverse of 6, or 6 is the multiplicative inverse of 1 by 6. So that is a inverse. Or in addition, I will take 5. In which number 5 added we get 0. The only one chance is a -5. So now we say -5 is the additive inverse of +5, or +5 is additive inverse of -5. We add these two, we get an additive identity. So we say -5 is the inverse. In the same manner, in matrix also some inverse is there. Suppose the given matrix is A. We denote the symbol of inverse is A inverse. In matrix, the inverse of A is denoted by A inverse. We say A inverse is the inverse of A. It satisfies one condition. What is the condition? The condition is we multiply the matrices A and A inverse. A and A inverse. We get an identity matrix. It may be 2 by 2 or 3 by 3. We multiply these two matrices. One matrix is A. A inverse is also another matrix. Suppose we multiply these two matrices, we get an identity matrix. We come to the conclusion one is the inverse of other. That is, A is the inverse of A inverse, or A inverse is the inverse of A. You know what is the value of I? Capital letter I indicates the identity on unit matrix. Suppose its order is 2. We write it is I2 on I. Simply we say I2 2 means it refers order. 2 by 2. So 2. I2 or I. Whose values are? 1, 0, 0, 1. Suppose it's 3. Order is 3. We put only 1 3 because it's a square matrix. So 3 by 3 we write 1. So in our question it may be given in shortcut form I or I3 also. I or I2. So you remind what is the value of I3 or I? Whose values are? 1, 0, 0. First row. Second row? 0, 1, 0. And the third row? 0, 0, 1. So it is a value of the identity matrix. Okay, it's called the identity on unit matrix. Two matrices satisfy this condition. We come to the conclusion one is the inverse of other. Next one is important. When A inverse is possible. When inverse is possible. The given matrix is non-singular, only A inverse is possible. Because the formula of A inverse, okay, is 1 by determinant A into adjoint. So it is the formula of A inverse. The given matrix is A, whose inverse is A inverse, and whose formula is 1 by determinant A into adjoint. We know how to find adjoint of any matrix, and you know very well how to find the determinant of any 2 by 2 matrix. Now I say again, A inverse is when possible. A inverse is possible only when the given matrix A is non-singular. Because you see in our formula, determinant A lies in denominator. Suppose the determinant value becomes 0, A inverse is impossible because 1 by 0 is not different. So inverse is possible only when the given matrix is non-singular. So A is non-singular, then A inverse is possible. Suppose A is singular, then A inverse is does not exist, or A inverse is impossible. So it is a formula of inverse. The given matrix is A, whose inverse is A inverse. Suppose the given matrix is D. So what is the formula to calculate D inverse? In the same manner, the formula of D inverse is 1 by determinant D into adjoint D. So now we see how to find the adjoint of a 2 by 2 matrix and how to find the inverse of a 2 by 2 matrix. In exercise, the first one, find the adjoint of the following. So matrices is given. The first one, find the adjoint of the following matrices. Is the first one. You see the name of the matrix is not given. A, B, C like this is not given. So if we take the name of the matrix is our choice. It may be the name of the matrix is A, B, C is your choice. But all the matrices are denoted only by the capital letters. So it's the first term, so I will take the name of the matrix is A. I will take the name of the matrix is A. So if we take, so it is right. Or, sir, I will take it is the name of the matrix is B, C. Okay, We take from A to Z. So A value is minus 3 plus 4, 6 and 2. Our question is to find the adjoint of this matrix. We will take the name of the matrix is A. Now to find the adjoint of this matrix. What is the symbol of adjoint of A? We write it is ADJ of A. ADJ of A. We write ADJ of A, that means we find adjoint of the given matrix A. What is the working rule? What is the first step? We interchange the leading diagonal elements. What are the leading diagonal elements here? Minus 3 and 2. We interchange. So minus 3 and 2. We interchange. It becomes 2 minus 3. And the next step, change the sign of the remaining 2 elements. Plus 4 is there. So we put minus 4. Plus 6 is there. We put minus 6. So it is the adjoint of the first matrix A. It's the first one. First we see some 2 by 2 sums. So we write 2 by 2 adjoint. Find the inverse. You see in bracket, if it exists, of the following. If it exists means determinant is non-zero, then A inverse is exists. Determinant become a 0, A inverse is does not exist. So find the inverse if it exists of the following. You see here also the name of the matrix is not given. That is ABC like this is not given. So first step, we will put the name of the matrix. I put the name of the matrix is again A. Let A is equal to minus 2, 4, 1, minus 3. So the first step we will put the name of the matrix. Next, for our convenience, we will write the formula of A inverse. What is the formula of A inverse? The formula of A inverse is 1 by determinant A into adjoint A. So if we need inverse of any matrix, we need 2 values. The values are determinant and whose adjoint. So the first step to find determinant. Because determinant is non-zero, then only A inverse is possible. So the first step to find the determinant of the given matrix A. So now we find the determinant. Determinant A. Determinant symbol. And we write the elements of A. What are the elements of A? Minus 2, 4, 1, minus 3. Minus 2, 4, 1, minus 3. Now we find the determinant of this matrix. What is the working rule? We multiply the leading diagonal elements first. Minus 2 into minus 3 is plus 6. The next step, we multiply the remaining 2 elements with a minus sign. So minus 1 4 4. So determinant A is equal to 2. Okay, 6 minus 4 is 2. 2 is always non-zero. So determinant of the matrix A is non-zero, therefore A inverse is possible. The next step to find adjoint. Because the formula of A inverse is 1 by determinant A into adjoint A. We already find the determinant, the next one is to find adjoint. Now we find the adjoint of the given matrix A. How to find the adjoint of any 2 by 2 matrix? The working rule is, first we interchange the leading diagonal elements. Minus 2, minus 3 is there. We interchange, we get minus 3, minus 2. The next step, we change the sign of the remaining 2 elements. Okay, plus 1, plus 4 is there. So it becomes minus 4, minus 1. Now we apply this 2 value in A inverse. So A inverse. we already write the formula. So I directly apply the values. The formula of A inverse 1 by determinant A. So 1 by determinant A. The value of the determinant A is 2. So 1 by 2. Then adjoint A. The value of the adjoint A is minus 3, minus 4, minus 1 and minus 2. You leave as it is. Or, sir, I multiply 1 by 2 inside. Okay. It's also an answer. Suppose one or two students ask, sir, 1 by 2 I will multiply inside. Okay, that's also correct. You know, in a matrix outside any one scalar or constant is there, is multiplied each and every elements. Suppose the 1 by 2 multiply inside, the first element become minus 3 by 2. The second element become minus 4 by 2, then we simplify, we get minus 2. It's also an answer. Next one, 1 by 2 into minus 1, it become minus 1 by 2. Or 1 by 2 into minus 2, minus 2 by 2, we cancel, we get minus 1. But it's a enough step, is a value of inverse. So now we see how to find the adjoint and inverse of any 2 by 2 matrix. Adjoint is no problem, it's very easy. But in inverse also is very easy. First we check the determinant of a 2 by 2 matrix. Is non-zero, only A inverse is possible. Suppose whose determinant value is equal to 0. What is our next step? So determinant A is equal to 0. So A is a singular matrix. So A inverse is does not exist, or A inverse is impossible. The sixth one. If the name of the matrix A is given, whose values are 8, minus 4, minus 5 and 3. So one 2 by 2 matrix is given. Our question is to verify that A into adjoint, that is the product of these two matrices, and whose reverse reciprocal A adjoint A into A. So this product of these two matrices value should be is equal to determinant A into I2. So determinant A into I2. You know I2. I2 means identity matrix of order 2. So A into adjoint A and adjoint A into A value should be is equal to determinant A into I2. So given the name of the matrix is given, so we write it is A. The first step to find the determinant, because in our verification determinant is also involved. So the first step to find determinant of this matrix. So determinant A. So determinant symbol 8, minus 4, minus 5 and 3. Important in determinant we put only determinant symbol. We write in a square bracket, it is a matrix. We write within a two parallel lines, it is called the determinant. So important determinant symbol also. How to find this determinant? The first step, we multiply the leading diagonal elements. 8, 3. 8 3s are 24. Next, we put one minus sign. Then we multiply the remaining two elements. So I put one minus sign. Now we multiply these two elements. Minus 5 into minus 4. Minus 5 into minus 4 is plus 20. Determinant A value is 4. 24 minus 4 is 4. So determinant A value is 4. Next, we multiply A and adjoint A. So we multiply these two matrices. A is there. To find adjoint A. So the next step to find the adjoint of the given matrix. Do you know the working rule? The working rule is to find adjoint of any 2 by 2. We interchange the leading diagonal elements first. 8, 3 is there. We interchange, it become 3, 8. 3 occur here and 8 occur here. What is the next step? To change the sign of the remaining two elements. Sign, it become minus become plus, plus become minus. Minus 4 is there, it become plus 4. Minus 5 is there, it become plus 5. So it is a value of adjoint. Next, we multiply these two matrices. A into adjoint A. A is the given matrix. Now we multiply these two matrices. The first matrix is A. A is the given matrix. The value of the matrix A is 8 minus 4 minus 5, 3. And the next one is A matrix into adjoint. Adjoint A matrix value is 3, 4, 5 and 8. Now we multiply these two matrices. First, we take the first row of the first matrix and the first column of the second matrix. We move in the elements, so I put arrow mark. 8 3s are 24. Already you know how to multiply a 2 by 2 matrices. So I explained it. 8 3s are 24. Then we move in the element. What is the next element here? Minus 4. In first column, next element is plus 1. Minus 4 into 5 is a minus 20. So first row and first column. Next step. In first matrix, we will take the second row. And the second matrix will be take same first column. We multiply these two elements. Minus 5 into 3 minus 15. We moving, so we put arrow mark. Minus 5, the next number is plus 3. Here 3, the next number is 5. 3 5s are 15. So plus 15. So we do the same work in the next column also. Now we will take first row and second column. 8 4. 8 4s are 32. Next, we multiply these two elements. Minus 4 into 8 is a minus 10. Next, second row, second column. Minus 5 into 4 is a minus 20. 3, 8, 3 is a plus 24. Now these values are 24 minus 20 is 4. 32 minus 32 is 0. Minus 15 plus 15, 0. Minus 24 plus minus 20 plus 24. It becomes plus 4. You see any number is common in this matrix? One number is common in the matrix. What is the number? The number 4 is common here. So I will take outside the number 4. Then it becomes 1 0 0 1. We already explained. One matrix outside any one number is there. The number is multiplied each and every element. Now we multiply 4 and 4 is there. 4 into 0 is 0. So we take outside 4. Same 4 into 0 is 0. 4 into 1 is 4. What is the reason to take 4 outside here means the value of the determinant A is already fine. That value is 4. You see in our proof, determinant A into I2. A into adjoint A and adjoint A into A is determinant A into I2. You see the determinant A value is 4. So I will take outside 4. And also the next one is I2, identity matrix. You see 1 0 and 0 1 is the identity matrix. So I will take outside 4. So now we write it is determinant A. The number 4 value is a determinant A. And 1 0 0 1 is the identity matrix. In our proof is given I2, so I write it is I2. The next we find adjoint A into A. So one part is over. Next was reverse. Adjoint into A. That value is also will come determinant A into I2. Now we check. We multiply these two matrices. First row, first column. 3 8s are 24. 4 into minus 5 minus 20. First row, first column. Next, a second row in the first matrix, first column in the second matrix. 5, 8. 5 is plus 40. We move the element. So 8 into minus 5 is minus 40. Wow. Next, first row, second column. 3 into minus 4. 3 into minus 4, minus 2. We move the elements. 4, 3. 4 3 is plus 2. Next, a second row, second column. 5 into minus 4, minus 20. 8 3 is plus 24. Minus 20 is plus 4. Plus 12 minus 12 is 0. Minus 12 plus 12 is 0. 40 minus 40 is 0. Minus 20 plus 24 is plus 4. In this matrix, one number is common in all the elements. What is the element? The element is 4. So I will take outside the element 4. So 1, 0, 0, 1. So we will take adjoint into A. The product of adjoint A into A. The value is equal to 4. 4 is the value of the determinant A. So we write it is a determinant A. And 1, 0, 0, 1 is the identity matrix of order 2. So we write it is I2. I put it is equation 2. Now we come to the conclusion from 1 and 2. From 1 and 2. The value of A into adjoint A and adjoint A into A, that value should be is equal to determinant A into I2. In equation 1 also that value is determinant A into I2. In equation 2 that value is also determinant A into I2. So from 1 and 2 we come to the conclusion the product of these two it should be is equal to determinant A into